I'm going to be explaining to you the topic of electrolysis. To understand electrolysis, you need to first understand where the metals and the non-metals are on the periodic table. Metal atoms always lose electrons to form positive metal ions, and non-metal atoms always gain electrons to form negative ions. If we've got a sample, such as zinc chloride, zinc contains positive metal ions and chloride is a negative ion. So when we do the electrolysis of zinc chloride, the metal is zinc and opposites attract, so the zinc goes to the cathode, which is negative, and the chloride ions, which are negative, are attracted to the positive electrode, which is called the anode, and that's how they can be separated. If we go and see how that actually works in practice, here we can see in the fume cupboard we have solid zinc chloride. There the ions are not able to move. The ions can't move, so we need to provide a heat source, and that will allow the ions to move so that they can move to the appropriate electrode. We'll try and come back to that in a minute. Now, if we studied the electrolysis of a different example, for example sodium chloride, that, as you can see, is not a solid. So once again, we have the metal ion, which would be the sodium. We have the non-metal ion, which would be the chloride. But because it's dissolved in water, we call it aqueous. So we also have these ions present here. The H2O molecule, which looks like that, one oxygen atom, two hydrogen atoms, and one water molecule, can break into a hydrogen ion and a hydroxide ion. So the hydroxide ion and the hydrogen ion can also go into the electrolyte. Now, the ions can move because it's aqueous, but now we have a choice. The positive electrode could be the non-metal, which was the chloride ion, or it could also be the hydroxide ion. Now, what determines what goes there is if the non-metal is a halogen, the halogen goes there, or the halide ion always goes there. Now here we can see that it's actually chloride. Chloride is a halogen because it's in group 7 of the periodic table. So we find that the halogen the halide ion does actually go there. And as we can see from this, the halide ion will go to the anode, forming a chlorine molecule as a gas, and you would also lose 2 electrons. Now, the options we have for the cathode are the hydrogen ion and the metal ion. The metal ion, as we saw earlier, is sodium. So sodium, if we look at the reactivity series, sodium is above hydrogen. And if it's above hydrogen, you don't get the metal, you get hydrogen instead. So at the cathode, the hydrogen ion would go to the cathode, and the metal ion, which was sodium, would stay in the electrolyte along with the hydroxide ion. So at the cathode, which is where the hydrogen ion is, you would find that the hydrogen ion would gain 2 electrons, forming hydrogen gas. If we go over now to what we started earlier, we can see that the zinc chloride is now beginning to melt, which means the ions are starting to move, and at some point, if you look carefully now, you can see the light bulb. It might be difficult to see on the camera, but the light bulb is starting to light. Thank you very much for listening.